Hello students, here's micro lesson number 3. We're going to be talking about the distributive property. And I'm sure you've seen examples of this previously because this is not a new concept for 6th grade for many students or some students. But first I'm going to talk about what a parentheses sign actually means. So if we have, say, 3 on the outside, we have a parentheses, and we have a 2 plus 2. If we know PEMDAS, and we understand that 3 next to something means a multiply, we can't just multiply that 3 and 2 because this parentheses has to happen before the multiplication is occurring. So if we know that, then this stuff, we can just kind of call it, it's in a little group. If we think of these parentheses as a group or a bag or a basket, I think that's a lot easier for us to kind of visualize. So instead of numbers, let's think of it as a basket. Okay, we got a basket. It's a parentheses. That's what it looks like. This basket, and we just have a ton of fruit. We got some, let's see if I can get the right color. We got some cherries. And then we have some, let's say we have 1 blueberry in this basket, right? But how many of these baskets do we have? Oh, turns out we actually have 3 of these baskets full of 3 cherries and 1 blueberry each. So if we want to connect it to a real life example, say we bought 3 of these baskets and we want to know how many cherries do we have? Well, if we draw it all out, this is basket 1, basket 1, basket 2, basket 3, and we end up with 9 cherries, right? And then what about the blueberries? We can't forget about those. For basket 1, we got 1 blueberry. Basket 2, we got another 1 blueberry. Basket 3, we have 3 blueberries. So in total, we got 3 blueberries and 9 cherries. So how does that look in terms of math? Well, we can use, let's erase some of this extra fluff. 3 times this, but we can't only multiply by cherries, otherwise we're forgetting about our blueberries. And we can't only multiply by the blueberries, otherwise we're forgetting about the cherries. We can put a little plus sign, because blueberries and cherries aren't the same thing. We can't just combine those, right? So we end up with, let's keep using the same colors, 3 cherries plus 3 blueberries, right? And because we know still blueberries not the same as cherries, this is our final answer. That's it. That's as far as you can go. So that's our example if, say, we bought 3 baskets of these fruits and then we came back and it was like, oh man, I really want to know how many total cherries I have or how many total blueberries I have. Oops, I totally misdrew the cherries because it was 3 of these 3 groups of cherries. So if we wanted to rewrite that and simplify it, it would actually be 3 times 3 cherries plus 3 blueberries. All right. Once we simplify that, we end up with 9 cherries plus 3 blueberries. All right. So what does that have to do with variables? Well, again, when I first discussed the meaning of variables, they just mean unknowns. You could have replaced these cherries and these blueberries with variables like x and y or a number if you happen to know what it was. So I'm going to erase this and go over some examples with numbers. Let's see. Let's try the same numbers actually. So we'll have 3x plus 1. And you notice that there's actually nothing over here. We're not talking about blueberries or cherries, but let's take a look at what happens. Because we can think of this as a basket of all these things, and we have 3 of these baskets, we can write this as 3 times 3x plus 3 times 1. And our next step, we get 9x plus 3. And because 3 of just a number is not the same as 9 of the x, we can't combine those two things. And that's as far as we can go. But what if? Let's erase that first problem. These are our totals, right? We have our 9x plus 3. Oops. 9x plus 3. What if I got 3 baskets? I got 3 baskets, and I want to put those things somewhere, but I want to distribute it evenly. Well, since we already knew that problem, we could go back and just go back in the video and know, right? And so the problem here is, what if I just didn't even know how many baskets I had? I want to distribute this evenly. That's when we come back to our word factor. And if we remember our first video, or you can hop back there, I don't have a link, that's way too much work, but it's the first video I posted, MLS number 1. Factor is numbers that fit, or numbers that multiply with each other to fit inside a specific number. So if we look at these two numbers, 9x and 3, if we want to factor it, and I'll talk a little bit about why we want to factor it in a little bit, is, okay, we know 3 times 3, this is 3 times 1. We notice that these two are common, they share, or you could do the second. You could do the second 3 and that 3, doesn't matter. They're both shared by this. So factoring, remember, our meaning is numbers that multiply into our target, right? Numbers that multiply into our target. Then that means, let's go over here because there's more space. This whole thing. We could say that we could take a 3 out because we know a 3 is multiplying by both of these two pieces. And so if we have 3 of these baskets, per se, then how much are we left with? Well, we took out this 3 and we took out that 3. We're left with just 3 X's, or 3 cherries, or 3 strawberries, oranges, and we're left with just a 1. And so going backwards, why is that important? Well, in real life, if you wanted to distribute something evenly, once you had a big pile of everything, then you would have to go backwards in order to find this. So this is called factoring out this 3.